All right, so we are in section 9.3. And we're looking at prisms and cylinders. Okay. So a prism and a cylinder, first thing you want to know, these are three-dimensional objects, not two-dimensional. So it's a three-dimensional object. And it has two key things you're going to look for. It's got a base and it's got a height. And you need to know this. So the base of the prism is going to be two-dimensional. So that's what we've been working with. So a two-dimensional object could be a triangle, it could be a hexagon, it could be a rectangle. So any two-dimensional object you can come up with could be the base of that prism. The height is going to be one-dimensional. So it's just a typical height that you would know. And the height and the base are always going to be perpendicular to each other. So let me show you an example. Here, I'm going to switch over to Word and just manipulate a prism for you and help you see what I mean by base and height. I'll come back to the notes in a second here. Okay. So here, here's a prism, and I think I can move this thing around a little bit. So here it is. You can kind of get an idea of what that three-dimensional shape looks like. But the question is, what's the base and what's the height, right? Because we have options, because this thing can be moved around. And being able to locate the base and the height is going to be important. So how many sides does this thing have? It's got 5 sides. So which of the 5 is the base, right? We gotta pick. Is the bottom right here the base? If it is, then what shape's the bottom? Rectangle. Or is this the base? Is the base a triangle? Right? And it matters. And this is where it can get confusing. And so that's why I want to show you this. Here's what you want to think of the base as the bottom of this object. And the bottom could be anywhere. It doesn't have to be, bottom can be turned any which direction. But think of the base as the bottom of this object. The top of the object, the bottom and the top have to match, have to be the same shape. So if you do that, then it's going to be easier to identify the base. So if we thought, okay, rectangle, let's see, could that be the bottom? If that's the bottom, would the other side be a rectangle? Is it, would the top, no, the top would be like a point, right? So it's not working out. The top does not match the bottom if that's the bottom. So let's try something else for the bottom. What if I make this triangle the bottom? Would the top be a triangle? It takes a little visualization, but yeah, think of this kind of as a block of cheese, right? The bottom would be a triangular cut, and so would the top. The top would match the bottom, and so you've identified the base, because the base is going to be the same on the bottom and the top all the way through. That's really key to know that. And so identify that base. I'm going to draw in here real quick. So this part right in here is the base of the prism. Not sure where that likes to come up. Where would the height of the prism be? It's perpendicular to the base. So see how the base is a two-dimensional shape. It's a triangle. So then the height would be this piece right here, which is perpendicular to the base because there is a 90-degree angle there. So this would be the height of the prism. Okay. Now be careful. I'm putting prism height and base of prism because what shape is the base of the prism? A triangle. And when you find the area of a triangle, what's the area of a triangle? 1/2 base times height. So we're using that word base again and that word height again, but we're not talking about that base and that height. We're talking about a different base and a different height, and this is where it can get confusing. So the base of the triangle, we could say, well, let's let this part, right, this length here, be the base of our triangle, right? And so the base of the triangle is one dimension, it's just the length, where the base of the prism is a two-dimensional shape, right? And then the height of that triangle would be, whatever that vertical height, again, is perpendicular to the base. And so maybe that part would be the height of the triangle. So be careful not to confuse things like this, because this is where the confusion can enter in, right? A cylinder, here's our cylinder, and I'll move that around a little bit. So cylinder is kind of a can shape, right? But it's made of well, what shape is the base of this thing, right? So you have a circular base, right? Because if the bottom is a circle, the top is also a circle, right? And you guys you can visualize that. And so where's the height of this thing though? Okay, so circular base. All right, there's our base. And then this length right here would be the height. And again, you're used to thinking height has to be vertical. It doesn't have to be vertical because it could be laying on its side, and often it is. So I'm just showing you this to get you familiar with where to look and identifying what's height, what's base of these objects. Let me give you a problem to try now. So example 1. We got this right triangle here. Sorry, I'm not the best drawer here, but I'm trying to get that three-dimensional shape. So here's a prism, okay? And I'm going to tell you that the length from A to B here is going to be 10. The length from B to C is going to be 5. And the length from C to D is going to be, let's go 7. And I want the volume of this prism. So go ahead and try to find the volume of that prism. Oh, I should probably give you the volume formula for a prism. But I haven't done that, have I? I'm ahead of myself here a little bit. Okay, so volume formula of the prism is not that bad. It's this. The volume of a prism is equal to the area of the base times the height of the base. Sorry, the area of the base times the height of the prism. Okay? So we're talking about prism base here and the prism height, okay? And then that gives you the volume of the prism. So try to apply that to this picture here. Find the area of the base. So you got to identify what's the base times the actual height of the prism. And then that will give you the volume of the prism. So the base is the same top and bottom, right? That's one thing we want to know. So what shape is our base? Is it the triangle or is it the rectangle? Triangle. So here's our base, which is congruent to bottom and top are congruent. So that tells us that we can bring that 7 over. Okay, so we can bring that 7 over, and let's call this x. And we can find x using Pythagorean Theorem, because we have a right triangle. So x squared plus 7 squared is 10 squared. So x squared is going to equal 100 minus 49. So x squared is 51. X is square root of 51. We're going to need that piece because our volume is the area of the base, so the area of the triangle, which is 1/2 base times height. So we got another base, right? So root 51. What's the height of my triangle? If the base is root 51, 7. Okay, so careful here. So this, all this right here is for the base of the prism. But notice the square root 51 is the base of our triangle, and 7 is the triangle height. And so we still need one more piece, the height of the prism. And the height of the prism is perpendicular to the base, and so that's going to be our 5. And so now we have all the pieces we need, so our volume is going to be, well, 7 times 5 is 35, root 51, and it's all over 2, and there we have it. And when you're dealing with volume, make sure you cube your units, because it's 3-dimensional. Okay. And that's as much as we can do it in exact form. Okay, exact form would be without the decimals, without approximating. Okay. Question on that? All right. A cylinder is just like a prism, or pretty much is a prism with a circular base. So the difference, a cylinder, you know what the shape of the base is. When I say prism, you have no idea what the shape of the base is until you find that, okay, by looking at the shape. So a cylinder looks something like that, okay? And what do you think its volume is going to be? Area of the base times the height. But because we know the base is a circle, we can give a more specific formula. So what's another way to say area of the circle? Pi r squared, and we'll let h be the height. So that would be a simple formula for the area of a cylinder. So example 2. Let's say in the cylinder above, this length here is 10, and the diameter here is 8. Find the volume of that cylinder. And what are we getting? 160 pi units cubed. Units cubed. All right. So those are the basics. I mean, the rest of it is just trying different shapes out. And so I'm gonna stop there with the notes, and I want you to try the problems on your worksheets. Okay.